So the next units will be concerned with probabilities, and particularly with structured probabilities using Bayes networks. This is some of the most involved material in this class, and since this is a Stanford level class, you'll find out that some of the quizzes are actually really hard. So as you go through the material, I hope the hardness of the quizzes won't discourage you. It'll really entice you to take a piece of paper and a pen and work them out. Let me give you a flavor of a Bayes network using an example. Suppose you find in the morning that your car won't start. Well, there's many causes why your car might not start. One is that your battery is flat. Even for a flat battery, there's multiple causes. One is just plain dead. And one is that the battery is okay, but it's not charging. The reason why a battery might not charge is that the alternator might be broken, or the fan belt might be broken. If you look at this influence diagram, also called the Bayes network, you'll find there's many different ways to explain that the car won't start. And a natural question you might have is, can we diagnose the problem? One diagnostic tool is a battery meter, which may increase or decrease your belief that the battery may cause your car failure. You might also know your battery age. Older batteries tend to go dead more often. Then there's many other ways to look at reasons why the car might not start. You might inspect the lights, the oil light, gas gauge. You might even dip into the engine to see what the oil level is with a dipstick. And all of those relate to alternative reasons why the car might not be starting, like no oil, no gas, the fuel line might be blocked, or the starter may be broken. And all of these can influence your measurements, like the oil light or the gas gauge, in different ways. For example, the battery flat will have an effect on the lights. It might have an effect on the oil light and on the gas gauge, but it won't really affect the oil you measure with a dipstick. That is affected by the actual oil level, which also affects the oil light. Gas will affect the gas gauge, and of course, without gas, the car doesn't start. So this is a complicated structure that really describes one way to understand how a car doesn't start. A car is a complex system. There's lots of variables you can't really measure immediately. And it has sensors which allow you to understand a little bit about the state of the car. What the Bayes network does, it really assists you in reasoning from observable variables like the car won't start and the value of the dipstick to hidden causes like is the fan belt broken or is the battery dead. What you have here is a Bayes network. A Bayes network is composed of nodes. These nodes correspond to events that you might or might not know. They're typically called random variables. These nodes are linked by arcs, and the arcs suggest that a child of an arc is influenced by its parent, but not in a deterministic way. It might be influenced in a probabilistic way, which means an older battery, for example, has a higher chance of causing the battery to be dead, but it's not clear that every old battery is dead. There's a total of 16 variables in this Bayes network. What the graph structure and associated probabilities specify is a huge probability distribution in the space of all of these 16 variables. If they're all binary, which we'll assume throughout this unit, they can take to the 16th different values, which is a lot. The Bayes network, as we'll find out, is a compact representation of a distribution over this very, very large joint probability distribution of all these variables. Further, once we specify the Bayes network, we can observe, for example, the car won't start. You can observe things like the oil light and the lights in the battery meter, and then compute probabilities of hypotheses like the alternator is broken, or the fan belt is broken, or the battery is dead. So in this class, you're going to talk about how to construct these Bayes network, what the semantics are, and how to reason in this Bayes network to find out about variables you can't observe, like whether the fan belt is broken or not. That's an overview. Throughout this unit, I'm going to assume that every event is discrete. In fact, it's binary. We'll start with some consideration of basic probability. We work our way into some simple Bayes networks. We talk about concepts like conditional independence, and then define Bayes networks more generally, move into concepts like d-separation, and start doing parameter counts. Later on, Peter will tell you about inference in Bayes networks, so we won't do this in this class. I can't overemphasize how important this class is. Bayes networks are used extensively in almost all fields of smart computer system, in diagnostics, for prediction, for machine learning, and in fields like finance, inside Google, in robotics. Bayes networks are also the building blocks of more advanced AI techniques such as particle filters, hidden Markov models, MDPs and PAM-DPs, Kalman filters, and many others. These are words that don't sound familiar quite yet, but as you go through the class, I can promise you will get to know what they mean. So let's start now at the very, very basics.